Okay, guys, trying out new software and new stuff constantly, trying to give you guys a better viewing experience here. Here we go. Trigonometric ratios and right triangles. This is based off of what we did this morning in that video I sent this morning. Right? So, let me find a pen that works here. Still trying to learn this stuff. Like I said, draw. Evidently, yeah, there it is. Boom. Let's try pencil here. I haven't used this before. I'm going to draw in black. Cool. All right. So trigonometric ratios and right triangles. I want to remind you, we're going to use Sohcahtoa. I like to write it like this. Sohcahtoa. Right? And this tells me exactly what I'm looking for. Just a reminder, O means opposite, H means hypotenuse, and A means adjacent, the adjacent side to the angle, in relation to the angle that we're looking at. Now, in this case, it says find sine of beta in the triangle. Well, where's beta? That's right here. Okay? So we need the sine of beta. Well, we know that sine means opposite over hypotenuse. So we're trying to find the sine of this angle. That means we need the opposite angle. Opposite side, over the, what's H stand for? The hypotenuse. And hypotenuse is always opposite the right angle. So in this case, it's just 17. Okay? So that's this one. That's the answer to this one. This is actually a Khan Academy problem. So where's the words? Yeah, it says find sine of beta in the triangle. Okay, let's do another one here. Here's another one. Trigonometric ratios and right triangles. Find the cosine of beta in the triangle. Okay, find cosine of beta in the triangle. So let's find it. Well, here's beta. We know, once again, I'm going to write it every page. Sohcahtoa. This one's the cosine of B, or the cosine of beta, We know that cosine is, so this cosine is adjacent over hypotenuse. Well, what's adjacent to beta here? Is it the 12? No, the 12 is opposite, right? Adjacent is right here. So the adjacent side is 5, and then the hypotenuse is always the side opposite the right angle. So in this case, it's 13. So in this case, the cosine of beta is equal to 5 over 13. Next page. Cool, now I have 4 examples. This is from a random worksheet I grabbed online. So once again, I'm going to write these out. Sohcahtoa. Right? So number 1 here is asking for the tangent of z. So here's my angle z. And whenever I look over here, I know that tangent, that's what this T stands for, capital T, tangent, is equal to the opposite side over the adjacent side. Let me write that out. Opposite over adjacent. So in this case over here, the opposite side from angle Z is 21. So this is going to equal 21 over the adjacent angle to Z, which is 28. 28's adjacent to Z. It's really easy to figure these out because the hypotenuse is always going to be the side opposite the right angle. So in this case, so in number one, the hypotenuse is 35. In number two, the hypotenuse is 34. This is the hypotenuse, right? In number three, the hypotenuse is 35. In number four, the hypotenuse is 40. Okay? That's easy. Hypotenuse is always opposite the right angle. So cosine of C, number two is cosine of C. Well, what do we know about cosine? Cosine is adjacent over hypotenuse. So what side is adjacent to side C? That would be 16. And then we know the hypotenuse is 34. So cosine of C is just equal to 16 over 34. We're not going to calculate those or anything. We're just figuring out the ratios right now. All right. Sine of C, we know Sohcahtoa. Sine is opposite over hypotenuse. So opposite of C is 28 over the hypotenuse, which is 35. Number four, tangent of X. Tangent of X equals Sohcahtoa. Tangent is opposite over adjacent. So opposite of side X or of angle X is going to be 32. Adjacent to angle X is 24. There we go. So tangent of X equals 32 over 24. All right, let's see. Let me add another page here. I'm just going to add a page. I'm just going to give you some random, you know what? Let's see if I can use this. Never mind the shape. Boom. Is it working? Still trying to figure out how these tools. Anyways, I'll figure it out. Not right now. Here's a right angle. Let's just say this is QRS, and this is little r, little s, little q. What would you say the tangent of r is? What would you say sine of q is? What would you say cosine of r is? Okay, so tangent of r is going to be, just to remind you, tangent is opposite over adjacent. What's opposite r? Little r. What's adjacent to r? Q. Sine is going to be opposite over hypotenuse. Well, what's opposite of Q? Opposite of Q is Q. And the hypotenuse is just little s. Cosine of r. Cosine, Sohcahtoa. Sohcahtoa. Cosine's always adjacent over hypotenuse. That's going to equal, let's go to r. What's adjacent? Q is adjacent. Hypotenuse is s. So we can see that the sine of q and the cosine of r are the same thing. Okay. if you were to do, let's use a different color here. Boom. And let's use pen. I'll use a red pen and let's make it a little wider. So let's do sine of r and see what we get. Oh, that's too big. Oh well, we're using it. Sine of r equals, remember, sine is opposite over hypotenuse. Opposite of r, little r. Hypotenuse is always s. Okay, let's thin that out a little bit. And we're going to do cosine of q. Cosine of q. Cosine's always adjacent over hypotenuse. So cosine of q, adjacent is r, and hypotenuse is s. So you can see that the cosine of q and the sine of r are also the same. So you're going to notice that this happens in any triangle. So the cosine of q is going to equal the sine of r, and the cosine of r is going to equal the sine of q. You're going to notice this is going to happen in every triangle you use. All right, so hopefully this video was helpful for these trigonometric ratios, and we'll get that posted for you.